Introduction to Machine Learning. Machine learning is a method of teaching computers to learn from data, without being explicitly programmed. It involves using algorithms to analyze and identify patterns in data, and then making predictions or decisions based on that data. There are three main types of machine learning: supervised learning, unsupervised learning, and reinforcement learning. Supervised learning involves training a model on a labeled dataset, where the desired output is already known. Unsupervised learning involves training a model on an unlabeled dataset, where the desired output is not known. Reinforcement learning involves training a model to make a sequence of decisions, where the model receives feedback in the form of rewards or penalties. Machine learning is widely used in a variety of applications, such as image and speech recognition, natural language processing, and self-driving cars. Working with models in machine learning. In machine learning, a model is a mathematical representation of a system or process that can be used to make predictions or decisions based on input data. There are many different types of models that can be used in machine learning, each with their own strengths and weaknesses. Some examples include: 1. Linear regression, a simple model that is used to predict a continuous outcome based on a set of input variables. 2. Logistic regression, a model that is used to predict a binary outcome, such as whether an email is spam or not. 3. Decision trees, a model that is used to make decisions by breaking down a problem into smaller decision branches. 4. Random forests, an ensemble of decision trees that are trained on different subsets of the data, and then combined to make a final prediction. 5. Neural networks, a model that is inspired by the structure and function of the human brain, and can be used for a wide range of tasks such as image recognition, natural language processing, and more. When working with models in machine learning, the process typically involves: 1. Collecting and preparing the data. This includes acquiring, cleaning, and pre-processing the data so that it can be used to train the model. 2. Selecting a model and its parameters. This involves choosing a model that is appropriate for the task at hand, as well as selecting the parameters that will be used to train the model. 3. Training the model. This involves using the prepared data to train the model, so that it can learn to make predictions or decisions based on new input data. 4. Evaluating the model. This involves using a set of test data to evaluate the performance of the model and determine its accuracy. 5. Fine-tuning and optimizing the model. Once the model has been evaluated, it can be fine-tuned and optimized to improve its performance. 6. Deployment. After the model is fine-tuned and optimized, it can be deployed in production to make predictions or decisions on new data. Advanced formulas and concepts of machine learning. There are many advanced formulas and concepts in machine learning that are used to improve the performance and accuracy of models. Some examples include: 1. Gradient descent, an optimization algorithm that is used to find the minimum of a cost function. 1. It works by iteratively moving in the direction of the negative gradient of the cost function, until it reaches a minimum. 2. Backpropagation, an algorithm that is used to calculate the gradient of the cost function in neural networks. 2. It works by propagating the error backwards through the network and adjusting the weights accordingly. 3. Regularization, a technique that is used to prevent overfitting by adding a penalty term to the cost function. 3. The most common types of regularization are L1 and L2 regularization. 4. Dropout, a technique used in deep learning to prevent overfitting by randomly dropping some neurons during the training process. 5. Batch normalization, a technique used to normalize the inputs of a neural network, which can help to stabilize the training process and improve the performance of the network. 6. Ensemble learning, a technique that combines multiple models to improve the overall performance. 6. The most common ensemble techniques are bagging, boosting, and stacking. 7. Transfer learning, a technique that allows a pre-trained model to be fine-tuned for a new task by using the knowledge learned from the previous task. 8. Autoencoders, a technique that uses neural networks for unsupervised learning, where the goal is to reconstruct the input data. 9. Generative models, a technique that can generate new data that is similar to the input data. 9. Examples of generative models include generative adversarial networks, GANs, and variational autoencoder (VAE). These are just a few examples of the many advanced formulas and concepts used in machine learning. Each of these techniques can be useful in certain situations, depending on the task and the data that is being used.